Okay, hello and welcome to the gameplay multi-threading presentation for Tides of Revival. And in this presentation I will propose a way we can multi-thread gameplay for Tides and try to argue a little bit why and go over some details, and we'll see where we end up and what people think. So a couple of caveats. First, this is not really my expertise. I haven't done that much multi-threading. I know roughly what it's, what you can do, or what the problems are, and so hopefully I haven't made something silly, super stupid, but we'll see. And also, like, this presentation isn't really like it's not a GDC presentation or a presentation like for the YouTube or whatever. It's aimed at the team, so there are a bunch of things that are quite hastily described so that we as a team can discuss it later. But hopefully it should still be, a little bit valuable. Yeah, this is things that I've thought about as I've been sort of out on walks and stuff. So a lot of shower thoughts in this presentation. We'll see how it goes. And so I'm not really sure how good the solution is. It's not like I'm saying this is exactly how we should do it. This is one way we could do it. Is it good? I'm interested in hearing what people think about it before we actually go this route. Okay, so when you're seeing the proposal, it would be interesting to hear maybe afterwards what you think. Is this just, so bad you want to slap me? Is it just so bad you want to close the stream down and ponder life for a while? Is it like, this guy has no idea what he's doing? This guy is just... If it just sounds like I'm saying things that everyone else is saying and there's nothing new on the table, and why am I even doing this? Or you actually think there's something to what I'm saying, or I have like the best solution in the universe kind of thing. I think I'm probably gonna end up somewhere around here, but yeah, we'll see. A bit of a Swedishism here, but so just a quick recap on what Tides of Revival is. It's a big fantasy world game where tons of things are happening at various scales. Supposed to be heavily simulation based. So, as you're moving around the world, things are not just happening exactly where you are. It's actually like lots of things happening all over the world. Maybe there's a war raging over here while you're, over here doing stuff, right? Things like that. So it's a big world, lots of things happening. Even in like, when you're at a certain place, there could be like thousands of NPCs doing stuff, right? So we need to handle that. And this is, I think, not a super common, setup that most big games have. Typically, I think these days, what a lot of big projects do is they come up with this task graph, which is basically like, okay, as we run through the frame, we figure out exactly what needs to run and then spread it out over the course. And I think just the fact that we have so many different things going on, and also the fact that we want to have like mods, I can just see so many varied things happening in our game on such a big scale that it's hard to do the same thing, I think, without sort of occasionally the frame taking a lot longer than it would, or things like that. Which I want to avoid. And so like in like a typical RPG, like in Last of Us or Uncharted or something, you can just like, oh, it's taking too long, fix the graphics on level 3, right? And we will never be able to do that in this kind of simulated game. The player could attack a big spider nest and have all of the spiders come, and then he leads them into like a village, and then the villagers are fighting the spiders, and like who knows, right? And these aren't really things that we can plan for in the same way. And like when that's happening, you don't want suddenly the village from like 2,000 miles north to be like, well, I want to run my update now, even though it's going to be like a really chunky update because I'm a village that needs to run my simulation or whatever. I kind of feel like we have a slightly different problem here. So some of my goals here that I've come up with, these are probably pretty obvious in some sense, but it's quite important, I think, that based on the solution, I guess, maybe, but that we can't have like have this village that runs its tick, and a village simulation is super expensive, so it's gonna run for a long time, and then you're gonna get this big stall. We should try to avoid that being allowed to happen. I also don't want to have like a classic like just render and game, and like we fill up 4 cores and that's it, and like as much as we can, we should try to scale to the number of CPUs. I want to try to also avoid, which is kind of similar, but you could imagine a case where like if you have this big task graph, and like all of these sort of parts of it are sort of independent, and like some of them might think that okay, I'm gonna run 10 of my things now, and then maybe some frames they're gonna run like one thing, or like 10 things, or 100 things, but certain frames they're like multiple of them are gonna run like a lot of tasks, and that's gonna cause a spike, and that's also not good. I want the system to be debuggable, which means that I want to be able to have a player report a bug and send me a replay, and I want to be able to replay that so that in a deterministic way, and I can see exactly where the bug happens. I want to have mods, and I want the mods to be able to hook into the multi-threading. As I mentioned before, I want scalability, where scenes can be very, very varied in many different ways. Loading is another thing that we need. For example, a guard that's standing next to you is going to maybe update its senses once per second, but if they're on the other side of the town, maybe just once per minute or something like that, right? And then one of my goals is that we can have a game simulation that runs at 100 hertz. When I started thinking about this, I was thinking about like, okay, maybe we can have some things at like 100 hertz, like the weapon logic or interaction logic, and then we can have like the AI run at 10 hertz, and maybe the villages can run at like 1 hertz. And then I was like, but how do I like synchronize all of this to like together in a reasonable way? And I was like, that sounds very hard to do. And I was like, okay. So I was like, okay, no, let's just go for 100 hertz and solve that sort of thing. So I started thinking, well, really, there are kind of 2 types of work. Actually, I think there are like 5 that I will get into later. But one that I find is like, okay, things that absolutely need to happen every frame for practically all data. Like if you have a projectile, it needs to update, every frame rates. And then there's player logic, which is so this type of stuff is what I would call, or I think there's a term called trivially parallelizable. And what I really mean by that is that it's important that this runs really, really fast, right? And I think all of these should be possible to write to be really, really fast. And I don't think that's like a big problem for us to solve. Like, I mean, it's a big problem, but not like a architecturally hard problem to solve. I think it's just, okay, let's optimize animations or whatever. And then there's the play logic, which needs to run every frame. But on the other hand, it could be a lot of stuff with, the N is small, so it's not that bad, even if all of this is not super optimized. And maybe there are a few things in between. But then there's like another type of work. There are things that happen now and then throughout the game. So, for example, the village maybe collects its taxes once every 4 weeks in game time, right? Or the AI and the guard updates its sensors every second or whatever. And so this doesn't happen every frame. And some of them don't really care when they last happened, and some do. I'll get into that a little bit later. And some of them might be one-off, and some of them might be happening on a sort of schedule. And so with that type of work, I think we have some things that makes it so that we can come up with a special solution for that, I guess. And that is that, as I mentioned, some of them are like very, very short, and some are extremely long. And all of these, they don't really need to happen at one specific time. Like even if you have like a spear and you thrust it, it doesn't need to happen at exactly like 0.1 seconds after you thrust, right? That we check who you're hitting, for example. it could happen like at 0.1 seconds plus minus, 5 frames or whatever, and the player would never notice, right? Or like a village collecting taxes, that could be anywhere between like 3 and 5 weeks, for example. Not just, it doesn't have to happen exactly at the 4-week mark. And so when this is the case for these types of tasks, I also think that it's not actually a problem if they do take a little bit longer. It's a bigger problem for things like, checking if a spear hits, but it's a much smaller problem for like, if the village simulation takes, many frames or even like a second or whatever, it doesn't really matter so much. So I think we can sort of use that fact. And so the grand solution that I have is that we split the frame in two. So we do have one task graph, the AAA way. It doesn't maybe even need to be a task graph, but it's basically like, at the start of the frame, we just do a bunch of really hard optimized calculations that absolutely needs to run, and that needs to be super optimized. That's not really what I'm gonna get into here, because I think this is sort of like a solved problem in some sense. And so the real thing that I'm gonna talk about is this, and that is that we have a queue, and every time you wanna like schedule a task to happen at some point, you're gonna put it onto this queue, and it's gonna be sorted by time in some fashion. And these tasks have a time span when they can run, and they will finish not like exactly when they are queued to start, but rather they can, they start then and then they can finish a little bit later. So that's sort of the main idea here. And so we'll see where that leads us. So here's what that might look like. So in this example, we have 4 things in our queue. We have a spear that's gonna check its hitbox in about 0.15 seconds, but up to 0.2 seconds. We have a guard that's going to update its senses in, about 1.5 seconds. A village that's going to update its taxes, and it's going to do it within the next 1.5 days. So this has probably been in the queue for a while, right? Maybe it's, was queued 4 weeks ago, and it's just never had the time to sort of execute, and it's just been lying here, and now it's very, very due to run. And here's another village that was maybe just queued, and it is actually, scheduled to run in another 4 weeks. And of course, we're talking game time here, and when you're fast traveling and so on, you're gonna speed through the game at various speeds. I'm not sure how big this queue will be realistically. 10,000, 100,000 objects when you're playing the game. I'm not sure. I don't think it doesn't matter that much if it's super big, I think, because you're just gonna pluck things from the start as it's sorted, except for one thing which is loading, and I'm gonna talk about that a little bit later. Yeah, so this is what I envision a task looks like. So you're gonna enqueue it somehow, doesn't really matter how, and then what it's gonna do is it's gonna have 3 stages basically. First, it's gonna read from the game state, and then it's gonna go off for how long it wants to and do its calculations, and then when it's done, it's gonna apply them back to the game. And like the hope here is that the inspect and the apply parts are pretty damn fast, so that in the best of cases they should be like almost instant, right? And then the majority should be in here. And so this is what it would look like in the frame. So here we have 2 frames. First, we're doing some of these that I call continuous work, and then we have I'm gonna go back and forth a little bit. So we're gonna have tasks do the write step here. So because this is gonna write to the game state, and this is also gonna write to the game state. So that means that this green dashed thing here is basically when we have finished writing to the game state. Then we can start syncing to the render thread, or render sort of world, and we can start tasks that just read the world. And when both of those are done, we can start the next frame. And so another assumption here is that we can basically run this So, I mean, let's say that this stops here and we have a few extra milliseconds maybe, or just one or something. We can run this for exactly sort of, or almost exactly how long we need to, and then stop, right? So we don't accidentally run past it. Then we have like this, things that's just always going on the side, which is like a queue where we're sending things off to like the global sort of job manager, and we're just sending things off to be calculated. And then when they're done, they're gonna get applied here, and so on. So if we look here, here's what a task would look like. It would get queued somewhere here, and then it would inspect, it would calculate, and then it would apply in the next frame, or maybe like in the best case, it would apply in the next frame. Otherwise, it might apply even later on. So that's the idea. And there are some details that I'll get into. So here are the types of tasks that I think we can reasonably have, in a sense. So for example, a guard, it doesn't need to do its update on an exact recurring schedule. Like it doesn't have to be exactly every second, like on the dot, right? So it's a bit variable. It doesn't really have a duration. It doesn't really care about how long it's been since its last, sensor check. And so this means that different guards can really have, even if they have like the same config, in theory, one could be running updates faster than the other guard, just if it gets scheduled a little bit differently. And that doesn't really matter if one guard runs, in 1 hour runs 100 updates and another guard runs 90 updates. It doesn't really matter, right? A village tick or village simulation tick, that's also variable. It doesn't really need to happen on a specific tick, but it does have a duration. I think that's reasonable. Like if a village that runs its tick after 5 weeks probably wants to do some sort of calculation of, okay, what can happen within 5 weeks, right? Anything from like, did the mayor get assassinated? What's the the chances of that are higher if it's been 5 weeks than if it's been 3 weeks, right? Things like that. So it's still variable, but it needs to know the difference a little bit since the last run. I don't remember exactly what I was thinking here about May shift, but yeah, basically I think it's, if you start a village simulation on like the January 1st, it's not really guaranteed that it's gonna on average end up on like the first of every fourth month, or fourth week. But I think that's okay. I don't think that's a problem. But when you look at things like village taxes, I think there it's also fine if it doesn't happen exactly every 4 weeks. But it's important that it kind of thinks that it does, because it presumably taxes are supposed to be rounded up and calculated every 4th week. So maybe we can just let it think that it's gone 4 weeks, and then we need to basically compensate so that the next time it takes shorter or longer, which I think is fully doable and not really a problem. If we have something like an assault rifle, that's the case. Like both of these are not going to be part of this type of task queue. We have, because the rifle needs to fire at exact intervals, right? There's no really, it's not a duration. It doesn't really know how long it's been since the last shot, but it definitely needs to happen at an exact fixed rate where it's gonna look and sound really badly. And yeah, this is just like a line for the continuous work rate. Okay, so memes. How do we schedule this? I don't have the perfect formula, but just as an example here. So we have this spear and the village taxes. So in this example, both this exact frame, they are okay to run, like both of them. If we just sorted it by like the starting time, for example, the village taxes would run, but I think it's quite reasonable in this case to be like, okay, village taxes has a long runway left in which to run, so we don't want to run it now when we can run other more sort of high priority stuff. And so I just have like a few different calculations here. They aren't like super interesting or important, but I think they're just ways that we can think about scheduling these. Like this is clearly not a good way where we just check the percentage. Like, okay, the larger the percentage, the further we've progressed, the bigger the score of queuing early, right? And we remove the remainder. But in this case, this would still end up executing before, which we don't want really. And here are just a couple of other things where, you know, we get like the intended order where we execute this first, but, you know, this is, the difference here is so wild that maybe it's not a good formula anyway. Maybe we need a combination of this and this, I don't know. It's a solvable formula. One other thing that I think is important is also that when we sort this list, it doesn't have to be perfectly sorted, I think, right? It doesn't really matter if one task that should be run by, if it had like a perfect score, runs before another task that has like a slightly worse score, because of, you know, this whole like, right, this, right? It doesn't really matter if tasks run a little bit out of order. And it also, you know, you could imagine the case that, okay, it's gone 4.5 weeks and this village taxes has still not been able to run. Are we just gonna force it to run? I don't think we need to. I think it can just be like highest priority, you know, for the following frames until it starts running. I think this should be like a soft limit, and I think that would be fine. Okay, so here's something that you have probably thought about while seeing my presentation. What happens if the game state changes while you're off doing this calculation? Then your inspection might be totally wrong. Do you apply that? What happens? I found 4 ways to handle this, I think. First of all, we need like a validation step always before we do the apply. And so there's always a chance that, okay, the game state changes, but it's actually fine. It doesn't really matter. Like something in one village happened, but I'm calculating stuff for this village, right? So whatever. We could have the case where the game set has changed and it's quite relevant to us, but it's actually fine for us to just discard whatever we calculated and like hope that it gets picked up. Maybe you were maybe a guard that was like finding a target to shoot and like all of the targets died or something. If that's the case, it's just fine to them to be like, okay, I guess I'm not gonna find a target and I'm not gonna shoot or whatever, right? Or it could be that the guard aims and is like, oh wait, there are, out of the ones that I found, none of them were valid. I'm gonna try again, basically, right? And find new targets. Or maybe during the inspection phase, maybe we found like 100 targets and then we calculated the best one to shoot at, and then we validate and see that, okay, our target was dead. So, well, actually we can just pick the next best target, right? That doesn't really feel like a big problem. Task will definitely have, you know, dependencies. You could one example is, you know, the guard updated census and then it updates maybe its goals, because the goals need to know about what the guard thinks about the world, and then after the goals are updated, it needs to like refresh which current action it's taking or whatever. Or maybe after the taxes have been collected, the mayor needs to go and, you know, deposit it to the bank or whatever, right? So there are a few different ways we could do this stuff. We could modify, like we could insert like a step kind of here where you say that, okay, you have 2 tasks that depend on each other, and the way that is set up is that it's gonna, the dependent D or whatever is gonna insert itself into like the task of another task, which sounds a bit crazy, but I think it's not totally crazy actually, especially if you think about mods. You can imagine a mod actually totally modifying the way a task works, right? I think that it could be very powerful. We could run a task immediately, like synchronously, and sort of after another task has finished applying. Or we could run a task just, okay, this has now run, we're gonna, you know, run on the dependent one sometime afterwards. And so I think this one is not good. B is not good. C is pretty trivial, I think. The only thing you might have to handle is things like, okay, you have to ensure that the mayor collects the taxes before the taxes have been collected, you know, twice, right? I don't think that's a big problem. Uh, so I think C will solve most of our problems, but in A's case, what we can do is if we allow actually inserting or modifying these steps in a task in some way, some sort of, I don't want to get into details, but because I think that's, we can just figure that out later. But I don't think it is maybe super hard to do that actually. So I think this could be quite powerful and something to consider. Here's something that I've thought about, and I'm not sure how important it will be, but it's a little bit of a concern. Like, if we have this task here that's scheduled to run in 2 to 3 weeks, and this other task that's scheduled to run for another village slightly off from that, what we could do is, okay, we just combine them into one task, and it just, knows about both villages, and that way it can be faster. Maybe not so relevant for villages, but maybe if you have like 100 NPCs doing things, maybe you want them to, not run 100 different tasks, but maybe you just want 5 tasks bundled together, sort of thing. This is a very easy example that we could try, but yeah, I'm not sure if it's worth it, or if it could also be that just running one task per entity is just a horrible solution, and maybe this whole idea is worthless. We'll see. Anyways, some thoughts on replayability. I think if we do this, then we're gonna have like a replay build that our players can use. Like a special branch on Steam or whatever that's deterministic. And also, if we make it so that the tasks are applied in the order that they are sent off to be calculated, that means if my head calculations are correct, that it's enough to just store per frame how many tasks are applied, calculated, and inspected by my terminology. And if we do that, then it's not a lot of data, and we'll get perfectly replayable. And we can even, if we do this, we could even like not actually put it out on threads, but just play them out linearly, and that way we would get potentially easier debuggability of them, because we can just step as if it was single threaded. Loading. So here's a couple of examples of different types, really. So if you walk out of a village range, we don't just want to make the village sort of task itself run less frequently. We actually want to completely replace what's going on. We don't want to remove a bunch of tasks and add a new one. If you start like breaking into windows and stuff, that's a good time where we want to like make the guards more active. Or if an explosion goes off, then nearby villages want to, run away, right? And even here, like immediately, I think this is also a time where it's perfectly fine to say that the task needs to run, not just in like, okay, it needs to run next frame. To the villager needs to update its task, or its sort of sense next frame, which I think is kind of common. It's like, okay, something's happened, everyone needs to just update their sense of the world, which is super expensive. Instead, we could just say, okay, when an explosion happens, villagers need to update at some point within like now and 2 seconds from now, and that's still gonna look perfectly fine, and that means that they're gonna have 200 frames in which to run their updates, which should be fine, I think. Okay, so let's imagine that an explosion goes off. I think we can do something like this. We trigger an event that we have tagged as noticeable, and then we have the tasks are sort of divided into different types, and we can find all of the types that are interested in noticeable. So for example, because I really feel like a villager just out strolling in the world or in the village, it needs to take, it's not really allowed to use any more CPU than it needs for them to sort of pathfind around. It shouldn't be running any sort of, AI or ticking or checking if it's time to do something. It should just be extremely cheap, right? But it still needs to react, within a second or two when something happens. So we basically need to find all of those villagers that are interested. And so we don't really have one queue. We can have like one queue per task type or something. But you're still gonna like get, you know, the queue is still gonna, it's still one queue sort of conceptually, which is gonna like for each task type queue gonna get like the most, you know, best scoring one or whatever. I don't think that's a problem. Once it has that, it's gonna loop over all of those tasks and find the ones. For example, there might be 1,000 villager NPCs that have like a sense task schedule for far in the future, but this explosion is only gonna affect maybe the closest, the one within like 100-meter range or something. So we can find those, and that's probably gonna be specific for the task, I think. Or maybe we can do something smart there, I'm not sure. And then we're gonna, like, the easiest way is if this is just like a custom response for each task type, where it's like, okay, we got an explosion or we got a noticeable, we're gonna remove the sense task that's scheduled for far away, and we're gonna add a new one that's scheduled for the immediate future. It doesn't have to work exactly like this, but this is just an example of how we could do it, and I think this would be feasible, not super tricky. Because one problem is, of course, that like if we have 100,000 tasks, we can't just loop through all of them to find, you know, this data, I think. So that's why I want to kind of divide it into queues. If the performance isn't good enough to, you know, on a specific computer to do this work, then we can go down to 50 hertz dynamically, like maybe during combat or whatever. We can just slow the game down, and it doesn't really, I think 50 hertz will still be very playable, maybe even 30 hertz or whatever. And then we can go back up again when we want to. And this also is totally fine with like a replay build, like, because you can just record every frame, or like you can record when that sort of change happens. It's not a lot of data. Conclusions, I think this would be good for mods, because I think it would be pretty easy to write a task like this. I think in general it fits the game pretty well. I think the two things that I'm concerned about is what I've mentioned earlier, is like, okay, the read and write steps, are they really going to be super cheap, or are they actually going to be pretty expensive? Like, do they need to run a flex query, and that flex query is super expensive? And if so, can we fix that somehow? And I guess the second thing is like, okay, can we actually, like, how much of a guarantee can we make that it fits within like a, you know, 10 millisecond update window? But yeah, I'm very happy to hear thoughts on this. Feel free to say that it's not a very good solution, or that it's unnecessarily, maybe it doesn't need to be this complicated. Maybe we can just do the regular old solution, and that's totally fine. And I think that's me done. How many tasks can calculate at the same time depends on how many CPU cores. Yeah, so I think these calculation tasks will just be sort of competing with the same tasks that will also have running on like the renderer and the streaming system and things like that, right? So it's just going to be asked to, you know, sent off to some global job manager to like, okay, do this job whenever you have the time, and that job manager's, you know, job is to you know, put things out onto all of the cores, right? So yes, depends on how many CPU cores. I'm wondering about the case where you have n very long calculate tasks. Yeah, you know, you could end up with a case where you're like, oh, I accidentally scheduled, you know, 64 village ticks, and each of those takes like a second, and oops, now all of the cores are, you know, busy for 1 second. And exactly, so I think we can just, I don't think it's a big problem for us to tag every task type with, you know, an estimation of its costs, and it could be very broad, like cheap or expensive, right? and we could have just one core dedicated to running the expensive tasks, and then the rest are dedicated to running the cheap tasks, right? Yeah. And it's kind of the same thing for, streaming tasks, right? You want to stream in a bunch of data, and streaming can hitch on I/O and whatever, and you don't want to like accidentally try to load in 64 textures and have them stall, the whole game, right? So it's kind of the I was fast now. Yeah. But we can have big textures. All right, great presentation. All right, I'm gonna stop the recording, and I'll hope you enjoyed it.